So let's look at what's new in ER Studio 18.4. So this release is primarily around support for the Snowflake cloud-based data warehouse product. So we've configured our parsers to support natively Snowflake SQL code, which means that we can now import directly from a Snowflake platform. We can also generate Snowflake DDL scripts, which you've then got the option, obviously, to push directly to the Snowflake platform. We've also got core platform status, which allows us to import a Snowflake SQL file, a text file. And we can also generate alter scripts from our compare merge tool. So this is really important. So as the database changes and you've got an existing database on Snowflake, you can compare it with a physical data model and then decide which changes you want to propagate to Snowflake and generate the alter scripts for those changes, which then you can then deploy, or the DBA can deploy directly to the Snowflake instance. We also support the Snowflake data types, the full set data types. And then we've got some specific support for Snowflake features like clustering keys and setting the retention period on an entire schema or individual tables. You can also set the persistence of tables, so setting temporary tables or transient tables. We support the Snowflake specific objects, so indexes, functions, procedures, material views, schemas, users and roles. We've also done some extra work around data types in ER Studio 18.4. So we've got some new logical data types. We support now arrays, ranges, which we're going to see in Postgres, objects. We've added two new float data types, so 4-byte and 8-byte. We also support timestamps with and without time zone and a JSON data type. These are all the logical ANSI-based set of data types. We've then added new data types to Postgres as well, so namely the range data type set. So there's a number of range data types and the array. We also now support the identity property and also our special behavior. And this is fairly unique in data modeling tools. So ER Studio, when you set a primary key to be a serial data type, and now we support the big serial and small serial of Postgres. So when you propagate a foreign key from a primary key of type serial, it'll propagate the foreign key to be integer data type. As we're doing more around data types, we've built a new facility to be able to merge your data type mapping file. So the user-defined data type mappings that you've been creating in previous versions, you can now import those into 18.4 with a nice tool. And as usual, quality is really important to us, so we've included a number of bug fixes. So let's go and have a quick look at the Snowflake implementation. Okay, so here we are in Data Architect. Been through the usual process, created a logical model. From that logical model, I've then generated a physical model specific for Snowflake. Now you can see at the bottom of the screen, this is a Snowflake database. So in this model here, I've created a number of object types. I've created a materialized view, functions, a procedure, etc. Within the model, you can see the specific features for Snowflake. So here we've got data retention period, we've got the transients of tables, we can set up clustering information for the columns themselves. So I can set up data types. So these are all the specific Snowflake data types. And we can use this in the same sort of way that we do for any of our database products. Connecting to Snowflake is very easy. We're using an ODBC driver here. So if I want to actually generate a database, use the generate database wizard, I can specify to generate objects to a database connection. When I'm setting up my ODBC driver, then you'll put into the ODBC driver the server address, a default database, a default warehouse. I need to set up a role, so obviously a role that has all the privileges that you need to be able to create and read users, create and read databases, etc. So I've created a role here that has both security and sysadmin privileges. Once you've set up your ODBC driver, you just need to plug in your username and password as usual in the wizard. And again, it's standard stuff. I can go through and I can specify exactly what do I want to propagate to my database. So we'll send all of these objects over. Sequence, we'll create a materialized view as well. And as usual, we've got all the options. I can create users within the Snowflake database. These have already been created, so I won't bother creating them. I can create roles in the database and reverse engineer. I can create role hierarchies, which are unique to Snowflake. There's my schema object. Everything else is pretty standard. I'm going to make sure that I generate my owner around my tables. I could preview the SQL. In this case, I'm just going to finish, connect directly to Snowflake and deploy the resulting DDL script. So as you can see, it's now generating the DDL and it's going to be sending this over object by object to Snowflake, creating the model. There it is, done. If we hop across to our Snowflake console, I can see here I've got no tables in the model, but if I refresh, it's now created all of the appropriate tables. It's created our views, so we've got our two views that we created, one of them materialized view, etc. So there it is, successful. And likewise, we can reverse engineer this back to EL Studio. And the reverse engineering process is just as usual. So you create a new model, specify to reverse engineer. We've specified our Snowflake ODBC driver, username and password. This will now connect to the Snowflake instance, get a list of all of the databases and schemas on the server. Here I can see a list of all my databases. So I've selected my training database that we just created. Within that database, I can specify which schema I want to just reverse engineer. So we'll just stick to anything in the HR schema. We'll select all object types that we want to reverse and hit finish. And this will now generate for us a physical model. So as is usual, it'll connect to the database and start the reverse engineering process. Okay, and there it is. We've successfully reverse engineered. As usual, you can select whatever layout you want. So there's our orthogonal layout. And in the model, it's created for us a logical model. We use our naming standards template in here, so it's converted a lot of the physical names to nice logical names, which is standard functionality. And in our physical model, it's created for us all of the objects that were in the database as faithful representations in the model. And again, we've got the usual tools like compare merge. Now we can compare this with the actual Snowflake database and start to propagate changes. So that is the demonstration. And to summarize, EL Studio version 18.4 has got core product support for Snowflake. We've added some extra data types in the logical model. We've added some new Postgres features. We've updated Team Server to support Snowflake. Thanks for listening. You can find me at jamie.knowles@idera.com. Look forward to speaking to you soon. Thanks.